All right, we're starting our lecture on IDS and IPS, real short. Um, so again, as I said before, this is an advanced tool that's going to be able to make decisions, detect if attacks are happening, and actually prevent them, right? It's in the name, intrusion detection or intrusion prevention system. So what are we talking about? We're going to talk about these two different types of systems. Again, I'm going to use them pretty much interchangeably. However, there are some differences between them. And again, I'll say the differences are in the name, essentially where they act. Do they detect that something is happening and let you know? Or do they actually prevent things from happening before it happens? Okay. We're going to look at one in specific, Snort. It's super popular, very well known, and it's one of the most well used IDS IPS systems out there, open source. And we'll take a look at what Snort rules actually are, how to create them, do a little overview. I don't expect you all to become Snort experts at the end of this. We're going to have the rest of most of Blue Team phase to kind of work on some Snort things. But so think of this more as an introduction. Okay, so what are IDS and IPS systems? Again, they're pretty much interchangeable. And I'm going to use them interchangeable, and that's why you'll always see IDS/IPS. I'm sure you'll find people on the internet that will be pedantic, but like I said, it's in the name. It's either going to be detecting something and alerting you, or preventing something from actually happening. Again, right? Detection is more focused on catching, so like Snort. Prevention more focused on stopping, so like firewalls, if you want to think of it like that. Now there are trade-offs in using a more advanced system like this, right? If it is, you're making a copy of the data and you're going to analyze it generally. So if we think about the data flow into a system, we could place the firewall at the data flow and kind of stop things there. And we could place an IPS system in the firewall and stop things there before it goes through. An alternative approach would be, as the traffic's coming in, we split it. We make a copy, right? One that's going to go through normally, one that's going to go through our IDS and IPS system. What are the benefits of this? We're not going to slow down traffic, right? We're like splitting the flow into two ways. One way is going to go to our IDS IPS system, so we could take as long as we want to analyze. One is going to continue going on to the rest of the business section, so we're not slowing things down. This is another way that you might want to set up your IDS IPS systems. Okay, like I said, no perfect solutions, only trade-offs. So what do IDS IPSs do? Well, they can take actions. Very similar to firewalls, right? You have allow, you have deny. We have a new one now called alert. Let us know. And you, as a SOC analyst, oftentimes are going to be in charge of responding to alerts. Right? Some IDS or IPS system has already been set up. An alert gets popped or triggered, and perhaps it has a small message set up, and it is your job as the analyst to investigate this alert. We'll take a look at that. If I can give you an analogy to the physical world, this would be like, okay, you're setting up defenses. This would be like setting up some like strings and cans, so you can hear when somebody comes by, something like that, right? The cans making noise would be the alert, and you get to go investigate now. That's where we're thinking when we're thinking IDS IPS. Okay. There's different kinds. We have network-based IPS, and we have host-based IDS and IPS. Just like firewalls, we could place them in different places. Okay. They're generally capable of deeper packet inspection. So they're not just looking at the 5-tuple, right? Not looking at source port, source IP, destination IP, and protocol. They're going to look a little bit deeper. Perhaps they're looking at some of the context of what's been happening, right? Maybe you'll pay attention to, adding some state to the communications and not looking at just the individual packets themselves. Okay. Again, you're going to have trade-offs with uses. The deeper and more investigation you have, the more resources you're going to be using with this system. And that's generally why they're going to be split off to the side. So again, you have data coming in, you split that data off. One's going to your IDS IPS systems and logging. One's going to the rest of your systems, so you don't slow things down. Okay? That's generally one of the ways you'll have it. We can talk about detections. Okay, how do we actually find things now? How do alerts actually happen? Well, there's two main kinds of detections that we can look for with IDS and IPS. Okay. First kind are signatures. Can anyone give me some examples of signatures and where we've seen signatures and how, give me an example. What am I talking about here when I talk about detection signatures?
Like a certain kind of malware that
Tell me
acts in
more.
a certain way or has certain characteristics in its code.
Yeah. Like what? What cryptography concept do we know for matching things like that?
Hashes.
Yeah, right. We could base things by hashes, signatures. We can literally look inside the packets and look at malware samples, right? We can examine the bytes, the individual packet bytes, and take a look to see if it matches any kind of malware. So we've seen this before, right? Antivirus generally works this way, where there are known signatures that it's looking out for. I would say that there's not really a lot of intelligence on the system. It's just like, hey, does this match? And as long as your signatures, have all of the malware, then you'll be able to detect them. And signatures get updated all the time. The SolarWinds hack very recently, FireEye just released a whole bunch of snort rules for helping you detect IOCs, indicators of compromise from the SolarWinds hack. So this is one way that we can detect and prevent things based on their signature. Alternatively, we have anomalies, right? So this is where we're looking for things that are out of the ordinary. We need a little bit more intelligence in order to be able to find these. Usually we're going to use some kind of heuristic or some kind of threshold. So give me an example of, something that would be outside of the baseline that you would say, hey, that might be an attack. What's something that might be obvious looking?
So like if network traffic is really, really sparse during a certain time of day, and then at a part when it's not so sparse, during that part of the day where it's not so sparse, it then becomes extremely sparse. So then that would be a heuristic anomaly.
Yeah, so changes in traffic like that. Either, all of a sudden there's no traffic or a ton of traffic. Give me a specific example. What's something that you would definitely be able to see? You've done them before.
Password attack? A brute force password
Yeah,
attack?
that's exactly what I'm thinking, right? Brute force password attacks. Now, again, since you're using some kind of heuristic or threshold, these need to be calibrated, right? 3 SSH attempts in 1 minute might be fine for some places, and that might be possibly brute force in another, right? It completely depends on what your actual baseline is for the system. And like I said, they usually, when you build these rules for anomalies, they're not going to be perfect the first time. Sometimes you'll get false positives. You'll get way more alerts than you can deal with, or you might not get alerts when you should be. Right? They constantly needed to be calibrated. Okay, but at the end of the day, there's only 2 things that we can look for: find things based by pattern signatures, find things based on some kind of heuristic or anomaly or threshold that we're looking for. If there's X amount of SSH attempts in Y amount of time, we're going to say, hey, throw an alert. Let's get an analyst to actually look at this data and see what's going on. Okay, cool. So here's an example of what this might look like. We have data coming in. We have a firewall that's blocking certain things from coming in. So we're looking at things after the firewall, and then we're sending them off to the different systems with this very elegant diagram here. So the first thing I'll say is IDS IPS rules are the start of a lot of investigations. Like I said, an alert pops up in your SIM, in your security interface, management interface, and then it's your job to take a look. Potential SSH brute force attempt. You go look at the logs now. Right. Potential data exfiltration. You go look at the logs now. I have one of my former students now. He had a good one during lunch. He told me he had to. He said he was joking, but he said he doxed someone that was playing RuneScape in work. And so they got an alert or whatever. He found out this guy's playing RuneScape at work, and they had to let his boss know. Right. So this is the type of stuff that you might end up seeing. One thing I do want to note is that because of the placement of our IDS and IPS system in this diagram, there's certain things that we're not going to see. What are we not going to see right now? Give me an example. Or what do we see, if that makes it better?
Anything that passes the firewall, we'll be able to see, but anything that the firewall drops, we're not going to be able to see.
Exactly. Exactly. I know you're like, oh, that's obvious, but like that's an important note to important distinction to make, right? There could be attacks that are happening, but our firewall's already blocking it, and we just have no idea now because unless we're looking at the firewall logs, if we're looking at just their IDS and IPS system, it doesn't see it, right? The firewall's already blocking it. Don't get me wrong, though, the firewall probably does have logs if they're configured properly that we could take a look at. Right. So again, as you look at these network diagrams and take a look at where firewalls are and where IDS IPS systems are, you want to be thinking about these things, just like MD said, right? You're not going to be able to see now with your IDS IPS systems any attempts, any type of attacks that got blocked by the firewall. You just won't see them. So be aware of those placements. The other thing I'll tell you is because of the nature of where this is, it's in line, right? It's in sequence, not in parallel. That if we're trying to do super deep inspection, we might affect or impact the availability of certain things. Data might get slowed down if we're investigating everything before it actually gets flown through. Right? I'll have another example of what it looks like. Okay. So we have an idea of where these systems are now and what they do. Let's get a little bit more specific with Snort. So again, Snort's an IDS system. It's going to tell you, it's going to detect for intrusions on a network, right? It's open source, which is fantastic, right? We love open source. It's widely used because it's open source and free to use. It comes bundled with a whole bunch of security suites, and it comes with a whole bunch of rules for free. Some of them are paid, but most of the rules are free. And then again, there's also a whole bunch of organizations that do post rules for different IDS and IPS systems. So you can be up to date in your SOC or in your organization. Again, the example I'll give you is FireEye just putting out a whole bunch of Snort rules for detecting SolarWinds IOCs. Okay, so what do? They're going to inspect packets and make decisions. Sounds very similar to firewalls, I know, right? You're just going to look at the packet, make a decision. But here are the decisions we can have. Alert is the biggest one, right? We generally are going to be using these IDS systems to alert an actual human to go take a look at something. Again, generally going to be signature-based, but they could also be heuristic-based. They could use rules and heuristics, and it absolutely depends on what it is you're looking for, right? You can have some kind of threshold for what you're looking for. Let's take a look at an example of what this is. Okay, so again, we have data flow coming from the internet into our wireless router system here. And in this case, it's being split. Like I said before, we are making a copy of the data and sending it over to our IDS IPS system. And we're making another copy of the data and sending it to our internal network. Things to be aware of here is that the firewall is now not in front of Snort. So we will be able to see absolutely everything this time. But we do have the firewall in between the internal network. So we are protecting our internal network, right? This is the standard way that you'll see it. It's a good balance between being able to investigate everything while also not impacting the availability, right? Cool trade-off. So here we have Snort in parallel. Number one, we have the packet decoder and preprocessors as the first part once the data enters Snort. And, generally what happens here is pre-processing, right? It's cleaning up all of the data. We're not going to really dive into the details of it, but essentially it's reconstructing based on the protocol what's happening, right? Snort comes with a whole bunch of preprocessors already that are already configured and that you can configure and change yourself. We're not going to spend too much time talking about them, though. The second part we have is that detection engine. That is the brain of Snort right there, the detection engine, that thing in green, that third part after the preprocessors. That's where we're going to focus on most of our efforts, right? So it has essentially a list of rules that it's going to check the flow against, very similar to a firewall. And if the flow matches, we'll do whatever it says, right? We'll either pass it on to logging, or alerting systems. And if there are no matches, we'll either ignore it or we'll block the flow, right? Very similar to a firewall. Okay, so there's the detection engine. We're going to either log it or alert it, and then we're going to have logging the output. So pass it on to the logging systems, generate some kind of logging output. We're going to work with a whole bunch of different kinds of alerts and logs, and then you'll know where your logs actually go, because that's another challenge, right? You get an alert. Where do you actually go and investigate that? Where do you actually get that data to investigate? Okay, so how do we actually write Snort rules? How do we tell Snort what to look for? Okay, we have an idea of how it works. We set it up kind of similar to firewalls. It has a list of rules. It's going to look for things based on those rules and do whatever we set it to do. So how do we write a rule? Well, every rule starts with a rule header. Okay. And the rule header, well, look, very similar to firewall rules, a little bit different though. It has an action. What are we going to do? And it has a 5 tuple, and it has a direction. Which way is the traffic flowing? Now, generally, we're going to write our rules from left to right, traffic flowing from left to right, just so it all makes sense to us as we're reading it. But you can also write them write it bidirectional as well, if you like. You can do both. Okay. So after you have your rule header, you have your rule options. Okay. And there's a whole bunch of rule options that you'll have to go ahead and inspect for, but there's 2 that we'll talk about. So again, what does this look like? Looks like this, right? We have our 5 tuple along with our action up top. And below that, we have our options. Okay. Nothing super bananas yet. That green bar, that rule header, should look very similar to firewall things, right? It has all the things in the 5 tuple there as well as action. So let's actually write a Snort rule now. This is the basic outline of a Snort rule. Okay, you have your action, protocol, source IP, source port, an arrow. And again, the arrow can be either going to the right or in both directions. Like I said, I'm generally going to write them going to the right. Then you have your destination IP and destination port, followed by parentheses, rule options. The square brackets denote where you're going to put those variables. You don't actually have square brackets. There's no literal square brackets in it. There are literal parentheses, and the fields are separated by spaces. Okay. So let's say I want to alert on network traffic for a web server. Okay, I want an alert whenever my web server gets something. Okay, sounds simple enough. So we need to start with the 5 tuple. So first tell me, what protocol am I going to be using? Talking about a web server.
TCP.
TCP.
Beautiful. TCP port. All right, we already got the first thing. Source port, or excuse me, source IP and destination IP. What are we going to use? I'm trying to block a known malicious IP address from reaching my here. Let's yeah, I want a known malicious IP address that's 10.10.10.10. And my web server is 11.11.11.11. Okay. So then I'll put the source IP would be 10.10.10.10. What would the source port be?
Any.
Agree. Hard agree. Destination IP.
11.11.11.
And destination port. It's a web
80.
server. Yep. 80. You can do 80, 443 if you want to SSL on there too.
Is there any harm in saying any?
Yeah. So that would say, so if we think about it like that, that would mean any connection from 10.10.10 from the malicious to our destination, as opposed to any connection from the malicious to to the web server.
But
I see what
why-
you're saying though, since it's
yeah,
a
why-
malicious IP
Yeah, it's
address, why don't
malicious,
we
so
just
why do we
block it?
care if they can access this at all?
That's a good point. That's a good point. I don't know. I'm making an example up. All right. Yeah, we could block, we could do any. I'll say generally you try and use the word any or anywhere as little as possible. You can be as explicit as possible. Okay. So generally source goes to destination. We have all of that. What else are we going to add? We'll add the action will be deny or block. And then the rule options might be like message, known malicious actor trying to reach our IP address, trying to reach our web server. Okay, so what does that look like? We're going to always start with the 5 tuple. Right? Get all of that information going from source to destination. Things can be any, just like we said, right? Remember, if it's the malicious server is reaching out to our web server, it's going to probably be using one of those ephemeral ports, one of those high ports, which is why we don't know what it'll be. So we'll say any. And then we have the rule options, the final part. What do we want to do when something actually matches this? There's 2 that are really important and should always be there. There's the SID, which is going to be a unique identifier. Okay. Every rule, every snort rule needs to have an SID. And it's specific to your instance of snort. It's not like your SID is going to be the same as my SID and they'll be the same rule, right? It's specific to your instance of snort. It has nothing to do with matching the traffic. It's really just an asset, like it's really just an identifier for the rule. Now it says generally those rules, those SIDs should be greater than 1 million. Reason being, Snort has reserved a lot of the lower number rules, lower number SIDs for their own rules that come with Snort. So if you want to write your own Snort rules, you're going to make the SID greater than 1 million. They have a whole bunch of rules already, and we're going to leave the rest of it between, where they end to 1 million as like buffer for them because they keep adding. The other rule that you're going to want is a message. Okay. This is for people. This is human readable so that when the actual analysts get something that pops up on their screen, this is what they're going to see. This is the actual thing that they're going to read, right? It's essentially a string that's going to say traffic to web server from malicious IP, right? If we're going to use it off the rule we just made together. Generally, it's only going to be read by people so they understand what's going on. It's not really for the machine, right? The reason being, a lot of these snort rules that we write don't make sense outside of context, right? You might write some snort rules to block certain things and you don't remember why. You get an alert that just says this rule is happening. Now you don't remember why you did it. It happens all the time. Right? So again, human readable, things won't make sense without of context. And it makes sense for like heuristics or thresholds, right? So that way you could say, oh, this was likely SSH brute forcing attempt. Take a look at it. And now the analyst knows what to do. Okay. There are more rule options than this, absolutely, but I'll say those 2 are probably the most important ones that should be there. A unique identifier for the rule and a human readable message for the rule. Okay, cool. Other ones are like certain flags, certain thresholds, certain packet bytes, etc. Okay. So here's our summary. IPS and IDS, what are they? Therefore, they are the equivalent of stringing up a whole bunch of cans around your house so that you know if someone comes by, right? You'll be alerted by the sound. Alternatively, they can also take actions beforehand and prevent things from happening, similar to a firewall. Again, I'm going to use them interchangeably. You will find people online that will argue, well, it's preventing, so it's IPS, not IDS. Oftentimes, they do both. We took a look at snort architecture. And what it does, again, it has some pre-processing. It has the snort brain, essentially, where it's going to match all of those rules. And then it goes into logging. That's where I want you knowing high level. And then we took a look at examining some snort rules and writing them. They're very similar to firewall in that you need to be aware of the 5 tuple and where traffic is going and coming. But they add a little bit more things to it, such as what options you want to add, a message, a unique identifier. All right. And that's all I have as far as Snort for now. Do we have any quick questions before I show you what we're going to be working on?
I have one quick question.
Sure.
So can Snort look at the data if it's encrypted, like SSH, HTTPS, or anything?
Great question. Should not be able to. Should not be able to.
Okay. Unless they're using their own certificate, maybe.
In general, you shouldn't be able to read the traffic between two encrypted parties. Otherwise, there'd be a big problem with that protocol. That'd be some kind of vulnerability there. So no, you should not be able to read encrypted traffic. Not with Snort. You won't be able to read that. What you can be able to read is, before the TLS handshake, you can get a little bit of context. Again, you have the 5 tuple, but you won't be able to read. You won't get that. You won't be able to read inside. Good question. Ooh, Anissa. Sorry, I'm reading chat now, and her stir-fried noodles with broccoli, carrots, and tofu sounds good.
It was delicious.